Today on Capechi's Corner, we're going to look at properties of logarithms. Now, there's a couple different properties we're going to use today. So if you want to write them down as we work, or if you want to pause it and go back and forth if you need to, that's fine. The first one we have is property of product property. So product we know means to multiply. So again, we have the words and symbols if that helps you. A lot of times I just think the example is probably the easiest way. If I can break down this argument into 5 times 6, multiplication goes with addition. I break that apart to two separate logs. So addition and multiplication are going to go together. Okay, you're going to use this a lot now that we're kind of past the basics. The same thing holds true when we have division, right? The fractions of division. Division becomes subtraction. So I kind of separate that argument into subtraction. So subtraction and division go together. Okay. All right. So let's look at a couple other things we're going to need. So one thing here is the power property, right? So what happens is if I have an exponent here, so I have log base 2 of 6 to the 5th, that exponent goes up front. See what happens? We just took that 5 and we put it up front, and that gives you a new expression there. Okay. Another property is if I have log base 3 to the third. So if the base and the argument are the same, then that answer is 1. Okay. Something else that happens as well is if after my base and my argument, if they're the same, that exponent, that becomes the answer. And this is why, right? We already said, for instance, here, that log base 3 of 3 is equal to 1. If I follow my property with my exponent, that exponent goes in the front, and then I have log base 3 of 3, right? Log base 3 of 3 is 1. I multiply 2 times 1, and I get 2. So you don't have to go through all that, but that's why that works. Okay, so let's look at a couple of examples. Now, on this one, we have a value. This is the value. If you were to put that in your calculator, that's the value. Log base 4 of 2 is equal to 0.5 to approximate the value of log base 4 of 32. Now, we already have log base 4. That's the same. So what we have to do in the next couple problems is we're trying to manipulate this number, our argument here, in terms of 2. What can we do with it? Okay, so what I can say here is log base 4 of 32 is the same as log base 4. Now, what can I do with comparison of 2 and 32? Well, 2 to the 5th power is 32. Okay, so what I'm going to do is I'm going to bring that 5 up front, right? My exponent, I have 5 times log base 4 of 2. Okay, so this is going to come down 5 times. And then log base 4 of 2, they give us a value right here. That's 0.5. So 5 times 0.5. So my final answer there is going to be 2.5. That's the value. Okay, let's look at the next one. This time we're dealing with log 5 base 2. So I need to do something with that 2. So log base 5 of 250 is equal to, now how can I incorporate the 2 with the 250? Well, that's the same as log base 5. I can take 2 times 125, right? 2 times 125 gets me to 250. So again, now I'm multiplying, right? So I'm going to add, right? We said multiplication addition goes together. So I have log base 5 of 2 plus log base 5 of 125. And we'll simplify from there. Okay, so I have log base 5 of 2 plus, now I need to get this either in terms of 2 or I can do try to work something with my base there. Well, log base 5 of 125, 125 is 5 cubed. So that's what I'm going to do with that. Log base 5 of 5 cubed. Okay, so now let's look at our final answer for some values. Log base 5 of 2 is the same thing as 0.4307. Now remember, log base 5 of 5 is 1. So my answer there is going to be plus, and then my answer there is going to be 3. That's the value of that. So when I add those together, I get 3.4307. Okay, let's look at another one. Same sort of thing. Okay, so I have log base 4 of 192. And from here, what am I going to do? So with 192 and 3, how can I get them together? Well, the first thing I can try to do is 192 isn't a multiple of 3. So maybe if I just divide it by 3, if I divide it by 3, I can see that I get 3 times 64. Okay, so that log base 4 of 3, I'm good with that, right? Log base 4 of 3, because I do have a value there. Now, 64, again, if I'm looking at that base, I can say that I'm going to add that, right? Because of the multiplication is the same as log base 4, and that is 4 to the third power. So again, as I get to my final simplification, this is 0.7925 plus, this is going to be 3, right? So 3.7925, and that's my final answer right there. Okay, on these next two, instead of just giving you one log to work with, I'm giving you 2. Okay, now the other thing, I can also remember log base 4 of 4 is equal to 1. So I need to get something that somehow multiples or something, addition, multiples, division of 3, 5, and I can also use 4. Okay, so if I look at the first one, log base 4 of 12, I realize working with 3, 4, and 5, I can work with 3 and 4 because log base 4 is really 4. Sorry, log base 4 of 12 is really 4 times 3. So that equals log base 4 of 4 plus log base 4 of 3. Log base 4 of 4 is 1, plus log base 4 of 3 gives me a value right here, plus 0.7925. So my answer there is 1.7925, and that's my final answer. Okay, I'll do the same thing with number 5. This time I'm going to rewrite that because that is log base 4. And I have, this is 4 divided by 5, right? It's really the same thing. Okay, so divide is subtraction. So I'm really going to have log base 4 of 4 minus log base 4 of 5. Now, this already has it broken down for me, so I can just kind of go right to my final answer. This is 1, right? Log base 4 of 4 minus log base 4 of 5 is up here, 1.610. So my final answer there is negative 0.610. Okay? All right, we're going to move on to some different type of problems now. We're going to talk about solving. Okay, so again, I have log base 3, log base 2. They're always going to have the same in what we're doing. We're still pretty basic. Okay, so I have 2x, and then I have plus, and I have 7. Remember, plus is the same as times. So I can say 2x times 7, right, because they all have logs. Log base 3 is equal to 28. So that gives me 14x is equal to 28. So x is equal to 2. All right, let's look at number 7. Same sort of idea. I have a negative. I have log base 4, log base 4. Okay, so I'm going to have 48 divided by 9 because of that minus sign is equal to 6, which gives me 6n is equal to 48. So n is equal to 8. Okay. All right, moving on. Again, I still have log base 2, log base 2, log base 2. So this time, remember, if a number's in front, it's really an exponent. So I'm going to bring that up top. So I have x to the 4th, minus means division, and then I have 5 is equal to 125. Now, if I cross multiply, this is over 1. So if I cross multiply here, I get x to the 4th is equal to 5 times 125 gives me 625. Okay, so from here, I need to take the 4th root of both sides. So x is equal to 5. Okay. Okay, and our last one today, this one's a little bit different. My answer is not in log form, right? All the other problems we've done today, my answer is in log form. So in order to do this operation and solve it, I also need that to be in log form, and I need it to be in base 6. So how do I do that? Remember, log base 6 of 6 is equal to 1, right? And if I had log base 6 of 6 raised to the second power, that equals 2. Right, we talked about that earlier. So that's really what we're going to do with this too. So I'm going to rewrite this. This is log base 6 of x plus log base 6 of x minus 9 And this is really log base 6 of 6 squared. Okay, now we're going to go from there. This gives me, again, I'm adding, so I'm going to multiply x, my x there, and my x minus 9 there is equal to this 6 here, 6 squared. Okay, so this gives me x squared minus 9x is equal to 36. Again, every time I have x power higher, to the second power higher, I bring everything to one side and see if I can factor it. My signs are going to be opposite. So I have factors of 36 that when I subtract, I get to 9. That's 12 and 3. So 12 gets attached to the negative sign because that's negative there, and then I get a 3. Now, because of the zero property, power property, oh, I forgot my x there. I have x is equal to negative 3 and x is equal to positive 12. Now I have to check that. If I go back up the top, do you see how that x is by itself? So this x to the negative 3 is not going to work. This is an extraneous solution. Remember, extraneous solution is a solution that it works when I solve the problem. I didn't make a mistake, but it doesn't work when I substitute it back in. Okay, so my final answer right there is going to be x to the 12. X is equal to 12. Okay, thanks so much for stopping by today. You have a good one.